Hey everyone, here's our math problem for today. Find the value of x given this exponential equation. 2 raised to x plus 4 raised to x plus 8 raised to x equals 39. X is a real number. What makes this equation different than the other exponential equations that we already solved so far is that we now have here 3 terms all raised to variables. Also in this problem, I'm going to teach you some algebraic manipulations where you can solve a cubic polynomial purely by factoring by grouping without using any synthetic division. And that involves splitting up terms and creative manipulation. So you can pause the video and see if you can solve this algebra challenge. Now let's solve this problem together. So when solving for exponential equations like this, always check if the base can be re-expressed so that you will have the same bases. In this case, notice that 4 is 2 squared, 8 is 2 squared. We now all have 2 as the base. And then we apply the power of a power rule of exponents to arrive at this. We multiply the exponents 2 and x to get 2x. 3 times x to get 3x. Now, this is not the desired form that we want. We want 2 raised to x to be the common base of all these 3 terms, and we can achieve that applying the converse of the power of a power rule of exponents. We can write this again this way, noting that multiplication is commutative. And this is now the form that we want because the bases are the same, and so we can use variable substitution. We let a be equal to 2 raised to x, and therefore, we now have here a very neat cubic equation. So this 2 raised to x is a, this 2 raised to x is a, and we copy the exponent 2. The same thing here, 2 raised to x is a, and we copy the exponent 3. Then let's rewrite this in the standard cubic polynomial equation. So the next step now comes with experience and some creative manipulation. What we are going to do is focus on this a squared, and let's split that as minus 3a squared plus 4a squared. Anyway, the sum of this would still be a squared. Also, focus on this green a, and we are going to split that as minus 12a plus 13a. All the rest are just copied. Now, why are we doing that? Notice here that this 4 and this 12 has a common factor of 4. This 13 and this 39 has a common factor of 13. This a cubed and this a squared has a common factor of a squared. In other words, we can group the terms together like this, and we can perform factoring by grouping. The common factor here is a squared. The common factor here is 4a. The common factor here is 13. So this quantity a cubed minus 3a squared divided by the common factor of a squared gives us the quantity a minus 3. The quantity 4a squared minus 12a divided by the common factor 4a gives us the quantity a minus 3, and the quantity 13a minus 39 divided by the common factor 13 gives us the quantity a minus 3. Copy equals 0 at the right side. Notice now that we have common factor a minus 3. So factoring out the common factor, we now have the quantity a minus 3 times. When you divide this by this, the result is a squared. Divide this part by a minus 3, the result is 4a. And finally, divide this part by a minus 3, the result is 13. So we have here 2 factors whose product is 0. That means each of these factors is equal to 0 from the zero product property. And for the first equation, we now solve for a to be equal to 3. And for the second equation, we have here a quadratic equation. Now, we know that from the variable substitution, we let a to be equal to 2 raised to x. So let's compute first the first equation, substituting 3 for a to arrive at 3 equals 2 raised to x. And then using logarithm, the exponent x is equal to the logarithm of 3 to the base 2. And using the change of base formula, we now have log 3 over log 2. Here, the implied base is 10, and that's common to both of them. And this has an approximate value of 1.585. Now for the second equation, since we are only after the real solution to this problem, let's check first the nature of the discriminant. So the discriminant is b squared minus 4ac. If the value of this is imaginary, then we will disregard the solution for the second equation. So let's check first if we will have here a negative radicand. B is 4, A is 1 and C is 13, so substitute in that formula. 4 squared is 16, minus 4 times 1 times 13 is 52. 16 minus 52 is negative 36, which is not a real number. Therefore, the only acceptable solution for us here is x is equal to the logarithm of 3 to the base 2 with this approximate value of 1.585. And so going back to the original problem, if we now check and substitute this value for x to this variable x, here is the result using Desmos graphing calculator. It was verified that the value of this is really 39. And therefore, we are now sure that our answer is correct. So this is indeed a very elegant algebra problem where you can learn a lot of tricks that you can add to your algebra bag of tricks.